All right, here's the homework: composition of functions, graphically and algebraically. So for the first 9 problems, it's asking us to use the 2 graphs provided. We have one that is f of x, and it's from 0 to 5, and it's just part of a parabola. And then we have g of x, which is this little shape looking kind of like a cube function. All right, so first, so once again, we're just going to recall about function notation. Remember that f of x is equal to y. So here we have f of 3. Now we have to pay attention to both graphs. This is the f graph, this is the g graph. So it's telling us that f of 3, so that x is equal to 3. So therefore, we're looking for the y value. So we go to x is 3. Then we go and find where it hits the graph, and it only hits at this point here, and we can see that it hits here, and the y value is -1. G of 2, that's going to be this graph. So they're telling us that x is 2, so we go to x is 2, and you can see that it only hits the graph at this one specific point, and the y value here is going to be 0. For f of g of 1, so we're going to start in the inside and work our way out. So we're going to look for 1 in the g graph. So over here I'm going to write g of 1. So g of 1, I go down, I don't touch the graph, but if I go right here, I can see I touch it, and the y value is 1. So now we know that g of 1 is 1, so instead of saying f of g of 1, we're going to say f of 1. And when we look for f of 1, since f is here, we go to the f of x graph. F is 1, we go up to where it hits the graph, and it hits right here. The y value is 3. And we just continue through this. G of -2. So G is the G graph, so that's the second graph. -2 is X. So -2, go to the Y value. The Y value is also -2. And now we're going to do F of, instead of G of -2, we're going to do F of -2. And so we go over here, and what we notice is when we go down or up, we don't touch the graph. So this value here, F of -2, it does not exist. Continuing on, g of f of 3. So we start from the inside, f of 3. This graph here, so f of 3 is -1 for the y value. We can see it hits right there. So now we're going to do g of -1. So g of -1, we go to -1 on x. We go up, we hit the graph there. The y value is 1. Now we do g of f of 0. So we start on the inside, f of 0. F of 0 here is a little bit tricky, but I know that it does hit at 8, so then my y value there is 8. So now we're going to do g of f of 0, which is now g of 8. So now we have g of 8. So g, go to 8. 8 does not exist because the graph stops at 4. So once again, this one does not exist. All right, on the next side, we have f of g of x is equal to 8. So here we can see the numbers on the outside, so we're going to start from the outside and work our way in. So on the outside is f, and the outside is 8, so we're going to say that f of x is equal to 8. Now this is a y value. We can see right here that it's y, so we're trying to find the x values. So here, I usually draw lines through the y values. So in this case, f of x equals 8. So if I were just to draw it here, we can see that it hits the graph right here at this 8 value. So when we go to find x, we can see that x is 0. So now we're going to take g of x and we're going to set it equal to this number right here. So g of x will equal to 0. Okay. So now I go to g of x equals to 0. So that's y equals 0 pretty much. I go through here, and I see that the graph hits at this point, which appears to be about -1.5. But it also hits at another point. We can see that it hits at 2. So these would be my solutions, my 2 x values for number 7. All right, let's take a look at number 8. Once again, we can see that it's starting from the outside, so we're going to say that f of x is equal to -1. So I'm going to go to the f graph, and this is a y value, so I draw a horizontal line through -1. and I see it hits the graph right here, and the x value is 3. So now, instead of saying g of x, we're going to say that g of x actually equals to 3. Okay, so from here, we go to the g graph, and we find 3 for the y value. We draw a line through there. And we see that it hits right here, and we're going to just estimate this. I would say it's about, I would say 3.75. It might be a little bit under that, but it's an estimation. And that's the only part it actually hits at, so this is my only answer for this one. X equals 3.75. Is it possible for this to work? Yes, it does work because we actually have a solution that x equals 3.75. So yes, it does work. And now for the last one, we have when is g of f of x equal to 4. So once again, we start on the outside, so we're going to say g of x equals 4. So here we go to y value of 4 in the g graph. And we can see that it hits right here at 4. So x equals 4. So hopefully you're starting to understand this. Now we're going to take f of x and set it equal to 4. So now we go to the f graph, and the y value is 4. And once again, we can see it hits at one value, and that looks about to be 0.75. So my only answer here is x equals to 0.75. All right, moving on. Numbers 10 through 11. So it's asking us to find the composition between fog of 3 and golf of 3. So f of g of 3 and g of f of 3. So this first one here, fog 3, is really f of g of 3. So I'm going to start from the inside and work my way out. So I'm going to start with g of 3. So here the g function is right here. So instead of writing x, we're going to put a 3 in that spot because that's taking the place of x. So 3 squared plus 6. 3 squared is 9 plus 6, which is 15. So we know that g of 3 is 15. Now I'm saying instead of f of g of 3, we are going to say f of 15. And now we're going to work that out. So here we have f of 15. So we go to the f function, so it's going to be 15 plus 1. Parentheses are not necessary because there's nothing multiplied or it's not raised to an exponent, so I can just say that 15 plus 1 is 16. All right, for the next one, golf 3 is read as g of f of 3. So now we start from the inside, f of 3. So we go to the f function, so it's 3 plus 1. Once again, you're going to always see me put it, when I substitute for x, I put in parentheses. This one, it's not necessary. I know that there's nothing multiplying or it's not raised to some exponent, so 3 plus 1 is 4. So now that we know that f of 3 is 4, instead of saying g of f of 3, we say g of 4. So for g of 4, we now substitute 4 into the g function, which is right here. So 4 squared plus 6. 4 squared is 16 plus 6. 16 plus 6 is 22. All right, for the next one, f of g of 3. So we start with g of 3. So here, the g function is here. This is an x value. So we find x, that's negative 5, 6, and 3. So there's 3. We want the corresponding y value, which is negative 1. So now instead of saying f of g of 3, we say f of negative 1. So now we go to the f, and we find the x value negative 1, and then find the corresponding y. So here it's negative 1, so y is 9. So my answer is the last one, which is 9. For g of f of 3, we start with the inside, f of 3. So here, once again, f, that's negative 1, that's 3. So the corresponding y value is 6. So now we're going to do g of, let's do it here, g of 6. So right here, negative 5, 6, the y value is 12. So therefore, this is my answer. The answer is 12. All right, on to the next one. Okay, so now we have composition of functions, and these are using expressions to substitute in. So g of h of x. Things I like to do is I just like to define them. So here we're going to say that h of x is right here, x plus 4. So we're going to substitute this expression in for h of x right here. So instead of g of h of x, we're going to write g of x plus 4. Okay. And let me go ahead and write that over here so I can have a little bit more space. So g of x plus 4. So for g of x plus 4, we're going to say that, so we're going to plug it into the g function. So right here, for x, we're going to change it to x plus 4. We're substituting in the whole expression, plus 7. Parentheses are not necessary, so there's nothing multiplying, so it's just x plus 4 plus 7. And hopefully you see that 4 plus 7 is 11, which gives me x plus 11 as my final answer. For the next one, h of g of x, we know that g of x equals x plus 7. So when we do h of g of x, which is x plus 7, we substitute x plus 7 into the h expression. So instead of x plus 4, it's parentheses x plus 7 because this is substituting for x, and then the plus 4. Once again, parentheses are not necessary. So x plus 7 plus 4, so plus 7 plus 4 is x plus 11. And I don't think these always come out the same. They don't. Just happen to be like that. All right, on to number 13. Number 13, once again, it's just substituting expression into another expression. So here I'm going to skip the part where I define it. So I'm going to go g of h of x. I see that h of x is x squared. So this would be g of x squared. So that's x squared substituted in. Now we're going to work this out. So g of x squared, we're going to take x squared and plug it into the g function. So instead of this, it would be x squared minus 2. Parentheses aren't necessary. And here you can see I can't actually combine those. Those are unlike terms. So my solution here, or my expression, is x squared minus 2. All right, for the next one, h of g of x. So h of g of x is x minus 2. Now we're going to plug x minus 2 into the h expression, so it's x squared. So we're going to substitute x minus 2 for x, and then square it. This one, write it twice, and then FOIL it out. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. Last, you're going to combine your like terms. So the only two terms I can combine are negative 2x and negative 2x. So your simplified answer should be x squared minus 4x plus 4. All right, moving on to the last 4 problems. Hopefully you're starting to see that it's not as bad and that numbers are pretty easy to use. So h of f of 3, I'll write this over here. And we can see the numbers in the inside, so we're going to start with f of 3. So we look for the f function, which happens to be the first one, which is x squared. So we're going to change that to 3 squared. So remember, we plugged this in for x, 3 squared, which is 9. So f of 3 is 9. So we're going to now substitute 9 in for f of 3. So this will say h of 9. So we look for the h function. There's f, g, there's h. So 9 minus 1. Parentheses aren't necessary, so 9 minus 1, which is 8. All right, on to the next one. So h of g of negative 2. We're going to start with the inside, g of negative 2, because there's that number. So g of negative 2. So f, g, so 4 times negative 2, which is negative 8. So now we know that g of negative 2 equals negative 8. So now we're going to take g of negative 2 equals negative 8, and we're going to substitute it into the h. So there's f, g, there's h. So h is x minus 1. So let's do h of negative 8. So that's going to be negative 8 minus 1, negative 8 minus 1, which is negative 9. All right, so now we're moving on to the last two problems. 16, be careful with this one because what you should notice is that we're actually solving for x. So we have a composition and we're going to set it equal to 32. So pretty much what I'm going to do is I'm going to simplify this g of f of x. So I'm going to start with g. I'm going to figure out what f of x is, and over here I see f of x is x squared. I'm just going to substitute it into the g function. So g is 4. So 4, plug in this for x. So when I simplify it, it is 4x squared. So now I know that g of f of x equals 4x squared. So now what I can do is I can substitute this for 4x, or substitute 4x squared for this expression. So now we have 4x squared is equal to 32. And from here we can solve this. First thing we do is divide both sides by 4. X squared is equal to 32 divided by 4 is going to be 8. To get rid of a square, we square root it. Don't forget to put your plus or minus. So x equals plus or minus the square root of 8. This would have to be simplified. If you've forgotten how to do it, there's a lot of ways. So x equals plus or minus 2 square root of 2. So really quickly, if I were to break this down using a factor tree or something like that, I would take 8, 2 goes into 8 4 times, 2 goes into 4 twice, and 2 goes into itself once. So I have a pair of 2's, which goes on the outside, so that's one pair of 2's, and whatever's left, 2 and 1, we multiply it and put it back in. So in this case, our final answer is plus or minus 2 square root of 2. All right, last one, f of g of h of x. And we can tell this is going to be, it should be 3 of them, right? X, there, yeah, okay. So we can tell this should be an expression because we have an x and not a value. So let's start with h of x. H of x, if we go over here, is x minus 1. So I'm going to do g of x minus 1. So I'm plugging h of x in for here, which is x minus 1, and I'm plugging it into g. So the g function is 4x, so 4 times x minus 1. We're going to go ahead and distribute that. 4 times x is 4x. 4 times negative 1 is negative 4. So now we know that g of h of x is equal to 4x minus 4. We'll do one last substitution, and this should solve it for us. So now we're going to take this whole expression and substitute it here. So it's going to say f of 4x minus 4. Substitute that into the f function, which is just x squared. So just like the previous one, we're going to write it twice. And we are going to FOIL it out. So 16x squared minus 16x minus 16x plus 32. Once again, the middle terms are the ones that can combine. So my final answer when I simplify it is 16x squared minus 32x. And I just realized that negative 4 times negative 4 is not 32, it is 16.